Alright, Newton's first law states that an object at rest will remain at rest, and an object in motion will remain in motion at constant velocity unless acted upon by an external force. Just to clarify, the external force has to be a non-zero force. Now, what do I mean by this? Force is a push or a pull on something, okay? So if you're pushing something or if you're pulling something, that's known as a force. Now, an object at rest, that just means that, let's say I have a ball, right? Let's say I have a ball, and it's not moving in any direction. That means that this object right over here is at rest. It's not moving anywhere. Now, I would like to focus on this first part. An object at rest will remain at rest. What does this mean? Well, if this ball isn't moving anywhere, right? Well, it's going to continue not moving anywhere unless it's acted upon by an external force. So let's say if I apply a force to it. So let's say this is me, not drawing a scale obviously, but let's say I apply an external force by it, aka I push the ball, right? So this is applying an external force. Well, this ball is now suddenly going to move, right? Well, if I was not there and I did not push the ball, well, it's not going to do anything. It's just going to stay at rest. Now, when an object is at rest, what you got to know is that the forces, whatever forces on the ball that are acting on it, they're going to kind of cancel each other out. All right, so think about this, right? If we on Earth, there's going to be the force of gravity, right? And this force of gravity is going to sort of pull this ball down towards Earth, the center of Earth. Now, if the force of gravity is pulling the ball downwards, why isn't the ball moving, right? If I put like a ball at a surface, yet the force of gravity is pulling the ball down, well, why isn't the ball moving? And the answer to that is there has to be another force that kind of counteracts the force of gravity. And that force is called the normal force. So this is going to be the normal force. And when an object is at rest, the normal force is going to be equal to the force of gravity. So they're going to cancel each other out, right? The amount of the normal force is going to be equal to the amount of the force of gravity. Therefore, this ball isn't going to move. All right. Now we're going to focus on the second part. An object in motion will remain in motion at a constant velocity unless acted upon by an external force. So let's say if I have a ball, once again, and I push the ball. Now, realistically, what's going to happen? All right, if you were to kind of like think intuitively of what's going to happen, what do you think will happen? Well, the ball is just going to, first of all, it's going to accelerate, right? It's going to gain speed in a certain direction, right? It's going to keep gaining speed in a certain direction, but then it's going to come to a stop. But this second part of Newton's first law is pretty weird because it says an object in motion will remain in motion. And this is pretty confusing because, well, if I push a ball, isn't it just going to stop, right? It's not going to remain in motion. What? How is that possible? Well, the thing is, keep in mind that there are actually forces that are sort of pushing this ball backwards. They are pushing this backwards, causing it to stop. And kind of the two main forces you're probably going to be focusing on, or you should focus on, is air resistance. Basically, this ball is going to hit a bunch of air, and this air is going to sort of push this ball backwards, right? It's going to resist the ball's movement, hence why it's called air resistance. Another type of force that sort of causes the ball to come to a stop is the force of friction. Right? Because, if we were to kind of zoom in on, let's say, the surface of where the ball was rolling, when the ball moves through these jagged edges, well, it's going to bump into these little kind of bumps, and it's going to slow the ball down. Think of it as kind of little hills that the ball has to go through, right? Whenever you roll a ball through like what seems to be a flat surface, in reality, most of the times it's not actually flat. It's going to be jagged. It's almost going to be like hill-like when you zoom in to kind of a molecular or like a very microscopic level. It's going to be very jagged. And this force of friction causes the ball to stop. Now, let's say if we were to roll a ball, right? Let's say if I was here and I rolled the ball, right? And I'm assuming that there's going to be no air resistance. So let's say this is a world where there is no friction, so this surface is completely smooth and there is no air anywhere. So there's not going to be any air resistance. Well, the ball is going to accelerate, and actually what's going to happen is this ball is going to keep on moving forever at a constant velocity. When we push the ball, it gives the ball its initial acceleration, but then after that, no other forces are acting on the ball, right? We're only pushing this ball at this one moment, and after that, we're leaving the ball on its own. So there's not going to be any other forces applied to it. So it's just after this initial acceleration, it's just going to keep on moving in a certain direction at a constant velocity. And yeah, that's Newton's first law, right? An object in motion will remain in motion at a constant velocity, right? So if there was no air resistance or no friction, our object would remain at motion at a constant velocity forever. However, in reality, there are other forces, other external forces like friction and air resistance that cause the ball to stop. So this is why, objects, in our world, they don't seem to kind of go at a constant velocity, right? Because there are other external forces that cause it to stop. But what Newton's now the reason why this is also called the law of inertia is because inertia is basically kind of the property of matter that resists change in motion. It's the object's ability to resist change. So, an object at rest wants to remain at rest, right? An object in motion wants to remain in motion unless it's acted upon an external force. So Newton's first law of motion is also referred to as the law of inertia, and it describes how objects behave according to their inherent inertia. So what I mean by that is, let's say if we have an object with a lot of mass. Let's say this mass is 50 grams, right? Well, if you were to send this ball moving, right? Let's say if I push the ball. Well, it's going to be pretty hard to stop this ball, right? It's going to take quite a bit of force to stop the ball. However, if I were to push on a smaller ball with less mass, let's say this is 20 grams, well, it's going to be much easier for the object to kind of be resisted, right? It's going to be easier for the object to kind of go from to motion to rest or to rest to motion, right? It's going to be easier to actually, stop the ball with less mass compared to stopping the ball with bigger mass, right? So objects with bigger mass tend to have more inertia. They're more resistant to change. And that kind of makes intuitive sense, right? Things have more mass. They're obviously going to be kind of harder to stop. They're going to be harder to put in motion, right? Because they have more inertia. They resist this change. While smaller objects, well, they're easier to move and they're easier to stop, right? And that's because they don't have enough, they don't have as much inertia as objects with more mass.